What impact will the existence of water bring to the tunnel? If in the construction stage, the groundwater of the tunnel reduces the stability of surrounding rock, especially the weak surrounding rock, it also increases the difficulty of excavation and support. And in the operation stage, the leakage of groundwater will cause corrosion of ancillary facilities in the tunnel and damage to the lining. In addition, water seepage will also cause the accumulated water on the pavement to freeze, which will affect traffic safety. Since water has such a great impact on the construction and operation of the tunnel, so how should we do the waterproof and drainage construction of the tunnel? After the tunnel is built, the original water system balance of the mountain is destroyed. The tunnel serves as a channel for groundwater accumulation near the mountain through which it passes. When the tunnel is connected with the water-bearing stratum and the waterproof and drainage facilities and methods of the lining are not perfect, tunnel water damage will inevitably occur. The tunnel water leakage is harmful with high difficulty and cost in remedy. Therefore, it is very important to carry out tunnel waterproofing and drainage. The tunnel waterproofing and drainage can achieve, nip in the bud, and get twice the result with half the effort. In order to avoid and reduce the harm of water to tunnel engineering, the principle of tunnel waterproofing and drainage must be followed. That is, the principle of combining waterproofing, drainage, blocking, and interception. Take practical and reliable design and construction measures to ensure the normal use of structures and equipment and traffic safety, and properly handle the surface water and groundwater. A complete waterproofing and drainage system shall be formed inside and outside the tunnel. Waterproofing. It refers to the waterproofing of lining, that is, to prevent groundwater from infiltrating into the tunnel from the rear of lining. Including the waterproof concrete structure, waterstop and waterproof layer. Drainage. The drainage ditch receives the water discharged from the drain hole and drains the water out of the tunnel. Longitudinal drainage ditches shall be provided for general tunnels except for tunnels that are dry and free of water all the year round, so that the surface water leaking into the tunnel and the accumulated water on the highway lane or in the railway ballast bed can be drained out of the tunnel along the line direction. Blocking. For water leakage sections, the grouting, spraying, water blockage walls and other methods are adopted to fill the gap between the support and the surrounding rock and block the groundwater. The methods adopted are shotcrete, grouting, formwork concrete, plastic board, etc. Interception. The surface water and groundwater shall be diverted and intercepted outside the tunnel, so that the water cannot enter the scope of tunnel works. Measures. Upstream drain tunnel, well point dewatering, ditching and diversion. After adhering to the 4 principles of waterproof and drainage construction of the tunnel, we will focus on learning waterproofing and drainage measures. First, let's start with shotcrete. Anti-seepage of shotcrete. Served as the waterproof layer, it is advocated by the International Tunneling Association. The IAT working team has done a lot of research on the shotcrete serving as the waterproof layer and pointed out that there are many influencing factors. As the waterproof layer of the tunnel, shotcrete is as important as the waterproof board. If this is ignored, the tunnel leakage will occur. The nail-free waterproof board in the composite lining of the mountain tunnel is the core of tunnel waterproofing and drainage technology, and is an important measure to ensure the waterproof function of tunnel. It is a high polymer waterproof coiled material with smooth impermeable surface. It not only plays a waterproof role of refusing the stratum water seepage from the secondary lining, but also plays a role in isolating and lubricating the primary support and the secondary lining, so that the constraint stress of the primary support shotcrete on the secondary lining model building concrete is reduced, thus avoiding cracks in the secondary lining and improving the waterproof and impermeability of the secondary lining. Waterproofing of construction joints and deformation joints. Construction joints are joints resulting from the construction of tunnel lining concrete. It is one of the weak links regarding waterproof and the most prone to leakage in the tunnel. If the construction joint of tunnel lining is not handled properly, it will not only cause cracks in lining concrete and water leakage in the tunnel, but also seriously affect the normal use and traffic safety of the tunnel, and will also reduce the strength and durability of the structure. In order to prevent cracks and damage caused by uneven settlement of the lining, settlement joints shall be set in sections with significant changes in geological conditions and uneven stress on the lining. In order to avoid lining cracking caused by severe temperature change or shrinkage during concrete setting, expansion joints shall be set. These two structures are collectively referred to as deformation joints. Deformation joints shall be waterproofed with flexible materials. Waterproof concrete. The secondary lining concrete of the tunnel is not only the bearing structure of external force, but also the last line of defense for waterproofing. Therefore, it is required that the lining should not only have sufficient strength but also have certain impermeability. In drainage tunnels, the drainage system behind the lining must be done well to ensure smooth drainage of water. The tunnel drainage system mainly includes the system of circumferential drainage blind pipes, longitudinal drainage blind pipes, side ditches, transverse drainage blind pipes, and central drainage pipes. Let's look at the picture below. For the groundwater seeping from the surrounding rock, it first passes through the circumferential drainage blind pipe between the rock surface and the primary support shotcrete, then flows through the longitudinal drainage blind pipe, and the water flow of the longitudinal drainage blind pipe enters the side ditch through the blind ditch outlet, and then it enters the central drainage pipe through the transverse drainage blind pipe. After this lesson, we know that the presence of water causes a lot of damage to the tunnel, and we also know how to carry out waterproof and drainage construction. Among them, the successful application of tunnel waterproof board laying technology without nail holes has largely eliminated the water leakage caused by laying with nails. This technology realizes the compactness and integrity of the waterproof layer and greatly improves the waterproof reliability in tunnel engineering. In our future study and work, we should also invent new technologies, new materials, and new processes through continuous practice and innovation, and contribute our own wisdom to the development of tunnel construction technology.